This is homework set 31 on variation. Question 1. We are told that y varies directly with the square of x. All right, first of all, let's just translate that. Here's what that means. Y varies directly means kx. I'll circle that so I can find it later. Now I know this. We're told that y is equal to negative 20 when x is 2. So let's substitute those values into our variation. And see if we can get k. So we get negative 20 is equal to k times 2. Let's divide. So we'll get k is equal to negative 20 divided by 2 is negative 10. All right, so this will give us now that y is equal to negative 10x. There's our variation equation. Now, we're told up here, right, I'm going to go back up to the top. Can you find y when x is 5? So let's just put 5 down in here. So we'll get y is equal to negative 10 times 5. So how about y is negative 50? Question 2, y varies inversely. All right, so y varies inversely with the square of x. So let's translate that. Now, as soon as I see y equals inversely, I'll draw a fraction bar and put a k on the top. Now, whatever follows the word inversely goes on the bottom. So y varies inversely, so fraction bar k, and the square of x. So the square of x follows inversely, so that's going to go on the bottom. There's our general variation equation. Now, we know this. Y is equal to negative 7 when x equals 3. So let's put these values into here and get k. So y is negative 7. That is equal to k over x squared. Now x is 3, so I'll get 3 squared. All right, so negative 7 is k over 9. Let's multiply. So we'll get k is equal to negative 63. Now, that will give us this particular variation equation. Y is equal to negative 63 over x squared. There's our particular variation equation. Now what we want to do is find y when x is negative 2. All right, so I'm going to put that negative 2 in here. So I'll get y is equal to negative 63 over, now be careful with the negatives, negative 2 squared. Y is equal to negative 63 over 4. And that is what we are looking for. Question 3 says that y varies inversely with the cube of x. Let's set up that general variation equation. How about y equals, now inversely. As soon as I see inversely, I write a fraction bar with a k over it. And whatever follows the word inversely, that's what goes on the denominator in the bottom. So the cube of x. So how about if we write x cubed? All right, there is our general variation equation. Now I know this. I know that when y is 192, x is 1/4. Or when x is 1/4, y is 192. So let's substitute these values into this general equation and solve it for k. All right, so we are going to get that y is 192. That will equal k over x, which is 1/4 cubed. All right, let's simplify this. So we'll get 192 equals k over, now 1/4 times 1/4 times 1/4 is 1 over 64. But now, do you remember what to do when you divide by a fraction? You invert and multiply it. Now, what we want to know is this. What is y when x is 1/5? So put that 1/5 right in here. So we will get that y is equal to 3 over 1/5 cubed. How about y is equal to 3 over 1 over 125? Now, there's that division by a fraction again, so let's invert. So we'll get y equals 3 times 125 over 1. Now, y equals 3 times 125, 375. Okay, there we go. Question 4, we're told that z varies jointly. Now, that means a multiplication. Z varies jointly with y and the square of x. Let's write that. So we'll get z varies. Now, no fraction bar because I don't see that word inverse. If the word inverse appears, you get a fraction bar. No inverse, no fraction bar. So z varies jointly, so just write the k. As soon as it says something varies, write the k, with y and the square of x. So there's our general variation equation. Now to get the particular variation equation, they're going to give us information about the relationship between z, y, x, and k. Now let's see what we can do about getting k if we know z, y, and x, which we do. Right here is what we know. Z is going to be 80, y is 5, x is 2. Put those values in here and solve it for k. So we will get that 80 is equal to k times y, which is 5, times x, which is 2, but that gets squared. So 80 is equal to k times 5 times 4, or how about 80 is equal to 20k. Now, let's divide. So we will get that k is equal to 4. Now, put that 4 back up in here, substitute that 4 for k in our general equation. This will give us a particular equation. So that will give us that z is equal to 4yx squared. Now, what is z when y is negative 6 and x is 4? All right, so what we want to do is find z. So find z when y is negative 6 and x is 4. So that will give us that z is equal to 4 times y, which is negative 6, times 4, x is 4, squared. So how about z is, right, do those two, negative 24 times 16. So z is equal to negative 384. Question 5. We're told that z varies jointly, so multiplication, with y and the square of x, just like we did back in question 4, it looks like. So I'm going to write that z varies jointly, so multiplication of y and the square of x. There is the general variation equation. Now, here's what we know. We know that if x is negative 2, so put a negative 2 in here, y is negative 4, and z is negative 128. So we'll put those back in here. So we will get a 128. That is equal to k times y. Now y is a negative 4, and x is negative 2, but that negative 2 gets squared, right? Because it's the square of x. So we will get 128 is equal to k times, now what do we get here? Negative 2 squared is 4. 4 times negative 4 is negative 16. Okay, let's divide. So we'll get 128 divided by negative 16. That's going to be k. So that gives us the k is equal to negative 8. Now, put that negative 8 back up into this general variation equation. I'll circle that in case I need it. And this will give us a particular variation equation. So now we'll get that z is equal to negative 8yx squared. There is a particular variation equation. Now, here's what we're trying to get. We want to find x when z is negative 896 and y is 7. Okay, so z is negative 896. That's equal to negative 8. Y is a 7, and then I'll have the x squared. So we'll get 896 is equal to negative, now 7 times 8, 56x squared. Let's divide, so negative 896 divided by negative 56, that is x squared. So x squared is equal to 16, and if we square root each side here, we'll get the absolute value of x equals 4. Remove the absolute values. Now we'll get x equals plus or minus 4. Or if you like, x is equal to 4 and negative 4. Now question 6. We're told that f varies directly with m and inversely. There's that word inverse, so fraction bar with the square of d. All right, so here's what I'm going to write. F varies. Now I saw that word inverse, so I'm going to put a k in here on the top. So fraction barring k. Now it varies directly with m, so the m will go on the top. Oh, so m will go on the top, and inversely, right? Inversely with the square of d squared. There is a general variation equation. Now, here's what we know. We know that when d is 8, m is 3200 and f is 250. So let's put those in. So f is 250. That's equal to k times m, which is 3200. And d is 8. So it's 8, but it's 8 squared. Okay, so let's get that k. So this is going to be 250 is equal to 3200 k all over 64. So I can do that division. So I'll get 250 is equal to, now 3200 divided by 64 will go 50 k. And now let's divide by 50. So k is equal to 5. And now let's put the 5 back up into this k right here in our general equation to get the particular equation. So we will get f is equal to 5m over d squared. That is our particular variation equation. Now, what do we know? We want to find d when m is 1,000 and f is 200. So let's put those in. 200 is equal to 5 times m, but m is 1,000, over d squared. So 200 is equal to 5,000 over d squared. Now, I'm going to multiply by d squared, so I'll get d squared times 200 is equal to 5,000. Let's divide by the 200. So d squared is equal to that 5,000 divided by 200. That'll go. So I'll get d squared is equal to, now, 2 into 50. That'll be a 25. All right, so square root each side. Square root of d squared is the absolute value of d. Square root of 25 is 5. Remove the absolute values. Now we get plus or minus, or if you like, d is equal to -5, +5. And that is the end of questions 1 through 6 on homework set 31.